So hello guys, I'm Alex. I'm the lead technical artist for most of the projects here at CRYENGINE. So there's a folder called characters. This folder we will need to copy into our CRYENGINE build. You can basically just grab the whole characters folder here and just put it in. Copy here. So it's basically game SDK. In that folder you usually have your objects. Back in the days we had our characters in the objects folder. But as the characters are not really objects but animatable characters, we decided to put them in the characters folder. So go to your CRYENGINE launcher, like to this folder, CRYENGINE 5.6. You can find a tools folder here. Tools. And if you go really down, you have CryTools installer. Just click this one, then you should get a window like this, and you just say install. You can just select everything, that's okay. Just say next. It will then install all the tools for Macs. So basically everything needs to be closed, like Macs needs to be closed, Maya and Photoshop, or you cannot install it. So if this is successful, you can try to launch Maya 2016. So all our environment artists and most of the character artists, they model everything in 3D Max. But all our animation rigging pipelines, everything is Maya. We then basically get all the files from the character artist. He just models it wherever he wants. And usually he gives me an OBJ or an FBX file, and then I will start to rig it. So if you all guys see this shelf, like called CRYENGINE, and you see these buttons, then everything was successful. And you can then create materials, export, and do everything. As I copied my character already over to my SDK build, I can open. You can open your path, like game SDK 5.6, game SDK. You can find then the characters folder you all copied in. If you open the characters folder, you can see a player mail, and then that's basically our folder structure. We go for characters, and then we split the characters in rigs. So if we have a player male and female, they split it into a male rig and a female rig. So in source, you can find a folder Maya, and in there's a player male setup. Just open this file. So let's say your character rigger already created a rig, or you downloaded a rig from the internet, which is the Maya rig. You have the skeleton, everything, and now you need to bring it into the engine. So this is going to be a lot of stuff. The CRYENGINE usually have a character, and the character is saved in a character definition file. So it's called a CDF. Within the CDF, you have different files, like a skin attachment and different attachment that basically defines the whole character. I will go through it then in detail. But basically, what we need is here the player male skeleton. This is just a normal triangle because we want to avoid having a lot of vertices in the CHR. And this is only there so the engine knows about the joints of the character. So if you click here, there's a little layer. You can turn it on, and then you will see the skeleton. You see the skeleton, the joints, everything, the root joint. So usually the rig already comes like this. So you have your root joint, you have your thigh, you have your calf, you have all of your stuff that defines your human. And then basically I get a character from character art. They gave it to me in OBJ or as an FBX. I just put it in, and then I have a rough thing on it. Here for that case I already skinned it because skinning is a long process and can take up a day, maybe 2 days. So skinning is basically, if you have a joint, I have a joint here, and I placed it on the shoulder, right? And here's an elbow. So if this joint rotates, I need to define which vertices of the character will follow the joint. So basically, if the character moves the arm up, you see these vertices are all follow. But what I can do, if I don't like it that it follows, I can go to Paint Skin Weight Tools, and you have your left upper arm, and then you can basically decide, okay, I want more influence on, like you see, on the left upper arm, and then the vertices go up. That's basically the rudimentary form of skinning. If the skinning is basically done, you will have a character that can move. Let's say the skinning is done, you're fine with it, you feel like, yeah, it's okay for a white box mannequin character, it's kind of okay. Then you want to bring this character now into the engine, right? So for that, you need a skeleton or CHR file. I already told you, we use just a triangle for that. You can see, and the triangle is skinned to a joint in the hierarchy. It just needs to be one joint in your export hierarchy. So your export hierarchy is basically with a root joint, pelvis and everything, and you can just take pelvis and just skin it to the player male skeleton. I already did it. And then it will have all the skinning information. So what you all can do now, select the player male, this one. If this is selected, you can go to Tools and then create Cry Export node, like the very first node. You click it, and then here in File Type, you can change the file type to character. So yeah, if you have problems, if there's a pop-up, just go to here, Load. Like sometimes it's not loaded, and if you click Load, it should load all the plugins that's needed. And if you then click it, you should come to the Create Export node, and you could now select the CHR. As soon as you selected it, just click Create, and done. He created a CHR. You can see it here in the outliner. It is basically just an empty group with another empty group with the skin attachment in it. And we export it as a CHR because we don't want to see the triangle, we only want to know the information that the triangle is holding. And that's all the joint count, the joint information, like where's the joint position for everything. So that's our first thing, that's our CHR that we need to create. Then we have our base body that we already skinned. This is now the base body type. If you click on this, same thing, Tools, Cry Export node, but then not CHR, go for the last one, character skin. So skin, create, all right. So now we have 2 export nodes. That's already enough. Maya is usually Y up. You can see it here. But most of the engines, I think all of them are Z up. So that is a bit of a problem. In Rise, we set the Maya to Z up, so it worked, everything good. But then we had a lot of problems in Maya when we tried to do cloth simulation or physics simulation, because Maya is really hard bound to this Y up thing. So to avoid this and to have the character in the right position in the engine, we have a small group I already created here. It's called Scene Root. The Scene Root is basically just turning Maya into the max 3D max coordinate space. So if you export it like this, and your root joint, because that's your main joint, has the same joint orient. Yeah, basically 90 degrees on X and 180 on Z. That's basically what 3D Max is. You just 90 degrees and 180. So, but this is already set up. You don't have to worry about this. The next thing would be, you already set it up everything, but he has no textures. And if you would export it now, you would get a replace me. So you can go to Material Editor, that is like on top here. This thing, if you click it, will open up the Material Editor. Maya don't have the concept of submaterials, but we kind of recreated material groups that kind of fake the submaterials. Usually I already got all the material files from character art. So I go in there, like in the player mail, you can have you can find a base body CE MTL. If you open this one, then say yes to all, because the character already has the material applied. And then you can see you have your material and you have 3 sub-IDs. So maybe character art decides the first ID is for the head, second ID is body, third ID is something else. But usually I get this from character art, and they're gonna decide it because I don't know what they're gonna do. So you can go right mouse button, select objects with material, and then you can see my character already has the material assigned. Right now there's a wrong texture path. So we want to see textures, because if you skin, and if you would skin it like on this topology, you never see, like sometimes there's something in the texture baked in and you don't want it to be stretched. So you would skin it here and maybe then you see the texture and it's stretched. So it's better to have the textures in. With the model selected, hold right mouse button and then go to Material Attributes. Then the Material Attribute Editor will be opened on the right. You can click this arrow right to the last tab and then go to blend. Here in color, you can click this one. This is just a small checkbox. You go in there and then you see here is already a path, and the path is wrong because I already set it up. So in characters player mail, we have our textures folder, and there we have some textures, and I think the right one should be the prototype character base color TIFF. If you just open it, character has a texture on it. And then you can see, okay, cool, it's a crash test dummy. It has animation on it, has the skinning on it, and now you're ready to export. So if it doesn't show your texture, there's a small button here, this thing. If you turn it on or off, it will basically just load in and load off the texture. So now we have another tab here, export. Now we are ready to export. We set it up the materials, we skinned the character, the rig is there, and we have the CHR file. So we can go to export, and you can see our export window basically. You can go in here, define an export path. That is usually he should, I think, be already in textures. Yeah. So you can just go one up, and it's there player mail, and just save it. That's gonna be basically your export folder structure. So everything you export, the CHR and the skin file will go there now. So what you can do now is just select everything, and then export selected. Then fingers crossed, no errors, no issues, because like sometimes there are some. Okay, the Maya part is kinda done now, for now. So we can all go to the CRYENGINE now. Okay, so the main tool we're gonna use here is the character tool. Tools, animation, character tool. In the character tool, let me just quickly go through, just really quickly, the UI. I'm gonna show you my preferred way with working with the character tool. And if you click one time on this button here, he will split it into two categories. And then you can just set this to either characters, or you can set this to animation, skeletons, compression, whatever you want. But I usually have this setup. I have characters, so I can see all the characters here. And here then I have the animation. So as soon as the character is loaded, I can see all animations that are available for this character. I usually tick off this thing as well, so I can read better. So we exported our character and everything. We can go now this tab here, and File, New Character. It will then ask you, where do you want to create the new character? So where do you really want to create the CDF, the character definition file? It's you should have a characters folder here, right? Everybody has it? Then you can say just player mail, that's it. On here, you can type the name for the player. So yeah, let's say we are doing Rice, it should be Marius. So everybody knows Marius is our main character, it's his name, everybody can find it. But you can just name it however you want it. I just call it player mail, because let's say we are in a prototype phase and we don't even know what character we're gonna have, we just know it's gonna be a male and female one. Create it. Now it created a player mail CDF file. On the right, you have now a lot of errors, because you need to define like a lot of stuff now. The first thing you need to define is the skeleton. So you click on this little button here. It will open up the asset. You can go to characters, player mail, and then you find your skeleton, your CHR file that you just right now exported. You can find it here, you can click it. You can see now a little triangle here that I mentioned. This is basically all the information of all our joints. If you guys go to display options, you click on display options, and then you can go to skeleton and click on the joints. If you do this, you can see, so our skeleton that we just exported is here. We can see all our joints, everything is there. You can click again on the player mail CDF, and here you have an attachment slot. It says there's no attachment, so you only have basically a naked skeleton right now. Nobody can see it, nobody can shoot it. You can go to attachments and say add another attachment, a new one. You can give this attachment a name. Let's say we call it body. So we named this one body. And then you have the type. We can have different attachment types. Maybe I can just go through the different attachment. A joint attachment, you guys already just created a box. You exported the box as a CGF, right? So it's a CRYENGINE geometry file. It's not skinned, it's not animated, it's just a static thing. Let's say the character artist modeled a helmet. A helmet is a complete static thing, should not move, there's nothing on it, you can just put it on the head. The character artist could export it as a CGF, and I could go in, say joint attachment, say which joint should I attach it to. You just don't need to do this now, I just demonstrated. You can say like, okay, I want it to be attached on the head. And then what do I want to attach? You can go in objects. Let's say I would need to find something, vehicles, sample bike. So you have a bike. And you attach it now. It's a CGF, it will follow the head. If the head is moving, the bike will move with the head. So you can attach whatever you want. And it don't need to have skinning like the other thing. Just remove this again. This is a joint attachment. A face attachment is basically the same, but it's not attached to a joint, so the head. It's really attached actually to the face of the geometry. This is right now very expensive because he's calculating every frame the position of the vertex and then the position of the CGF object to align it. So, but our animation coders, they work on it right now and they make it more efficient. But honestly, I never used face attachments. Like during Rise, Crisis, we never used face attachments. And that's the most attachment that I use. It's the skin attachment. This is basically for everything that has skinning information on it. So what we created right now. You can then have also a proxy attachment. The proxy attachment is then, it will basically just create a proxy on the, a collision proxy on the joint. And you can then define what kind of collision proxy should it be, but I will go through that later. And then you also have like P-row attachments and V-cloth. That's our cloth solver. So let's go for skin attachment. Everybody select the skin attachment. And then you can go into geometry. And then characters, player male. And then you see your base body skin. You see your skin file that you already exported just now. You can click open and you can see the character is there. So he already has the material right now assigned because we did it right in Maya. In Maya everything is set up. We exported so he already knows the skin attachment uses this material. But if you want to change it, there's still an option here for material and you can just give it a different material. I just would need to quickly select something and see if it even works. You see, you can just give it a different material and now it has the bricks on. But as the standard value material, it will always keep this one. So now we have our basic character in with the skin, with all the joints. What we can do now is right mouse button on the CDF and just save. So now you created your character and everything is safe. This is set to characters right now. If you set it to skeletons, because right now we set it up the character, we set it up the skeleton, and everything is exported to the engine, but the engine needs to know where is the path to the animations. So if I export an animation for this rig, I want to see it in the engine and I need to tell the engine where are the animations. So for that we would need to create another file, it's called CHR params. So you can remember it like CHR stands for character, and the params is just the parameters that define the character. If you go into characters, player, you can file a file. It is not created yet. It's called player male skeleton CHR params. If you click on it, it should open here a window, and it says animation events file, the DBF path, and everything. You can go to animation set filters. Click the tab here and then say insert. It will basically insert a thing like this. So here we can now define a folder where the animation should be saved. Usually it's in the characters folder and then player mail. So if we have different characters, we already know all the animations are in the character folder for this character. Player mail, you go in, say animations, and then just say select. So he will basically now say like, okay, every animation that is in this folder, I will show it to you, and you can play it on the character. The animate events file, you don't need to create it now, but it's used for VFX and sound. So if sound basically goes in there and creates footsteps for the character, they're gonna tag it and it's gonna be saved in the animation events file. You can just click here on create new events file and say a path and a file name. Just call it player mail, create, or just give it the name. Okay, you can save it. It will basically save the CHR params. You can then go into this tab again because you don't need the skeleton anymore. Everything for the skeleton is set up. You can set it to characters again to find your CDF. So the CDF is open and you can see now in the animation tab, like if you have the animation here, if it says animation, you should find a characters folder, player mail, animation, and there should be already an animation in it. If you click on it, okay, now we have our character in with an animation that an animator already created. Let's say you are an animator and want to create another animation. You can go into Maya. In Maya, you can already see that I already created an animation. We usually create this range of motion just to test and see if the skinning and everything works. It's just rotating every joint just a bit. You can export this animation, so you don't have to create a new one. How to export this? You can go to export path here. And here in the end, there's an anim manager. You can click on the anim manager. There's already the animation in it. Just for now, delete it. So your window looks like this, basically, an empty CRYENGINE window. You can click on new, and then you need to give the animation a name. So let's say if you have a walk or run or anything else. So this is now just a basic range of motion. So I usually call it diagnostic ROM. And I need to say what is the start and what is the end frame. Here, if I look at it, my frame is set to -2 and to 300. I can go in and say use range from time slider. So you will already use the range that you set. Put the start frame to 0 because like the -2 thing is something from me. So you have basically start frame, end frame. You can check if the end frame is like really 300. Yeah, okay. Here, the root. This is important. You need to define the export skeleton root for your character, which is under base rig, root. That is basically your export skeleton root. With this skeleton root selected, go to root and select, and then you need to give it a path. You already defined the path in the CRYENGINE. It's gonna be player mail animations. Click on animations and then save. After you saved it, click on add. And now you have your animation here in the CRYANIMATION manager. Let's say you have an animation from frame 0 to frame 100 and some walk, and then you're gonna start a new animation from 100 to 200, it's a run. And you want to have everything in one Maya file, then you can go in here, create a new one. If you want, call it whatever you want, like you did it here, and then you will have the stack here, and then you can decide which animation you want to export. So close this, and then you can see here, it's your animation name. You click on it, and then you say export selected anims. This takes a while. What he does is he takes the animation. The animation is usually on the controls. So he goes in there, bakes all the keys on every frame, on every joint, and then export this to the engine. You should be able to just go back to the engine, and you should see it here already. Like with a little star, that means, oh, it's new, it's not saved. You can now click it. If you click it, nothing happens because you need to right mouse button and then you need to say import. He will then create an anim settings file. He imported it, and then You click it and you see the animation you just created, or the animator created and you brought it into the engine. Okay, that was basically the most painful part, where a lot of stuff can happen, because there's a lot of files that need to be maintained with it. I can quickly show it to you. We created one skin file. The material file was already there. We created a CDF and we created a CHR file. If you are curious how the CDF is set up, it's just a normal XML file. You can right mouse button, edit with Notepad, and then you can see what's in there. It's just a simple XML where it's defined where's the joints, where's the skeleton, and then it defines what type is it. Oh, it's a CA skin. It's called body, and it's the path. It's just how it looks like in XML form. So let's say we have a Rise helmet here, and we want this helmet to be in the engine on the character, but we want it to move around. So let's say he has like flaps here. These flaps, they should need to move around, like when he's walking, and we don't want an animator to animate it, we just want the physics to handle it. So what we do, you would need to create joints for this helmet and export it. It will then go into the base character, and every character would have the joints. That's not what you want, because then you will end up with, like, let's say you have 10 helmets for the same character and they have all different joint positions. You will end up with like a lot of joints and bad performance, and everything will be bad. So to split this, CRYENGINE has something like, it's called skeleton extension. So let's say this is our full character rig, but we don't need all the joints just for the helmet. For the helmet, it should be enough just to have the head and maybe the neck. That's okay. So what we can do now, this is gonna be now super fast, but I just basically copy the root and I delete everything except for the joint that I want to be in the base CHR basically. So we already exported our base CHR and we have our joints that are basically here. That's our joints. But we want the helmet with joints here as well. So we have the helmet from character art. You can go in there, you duplicate your main skeleton, and you then basically just delete everything except the neck. So now you have a really, really simple skeleton here with just 3 joints. It's just the root, the neck with the same neck position as your character, and the head with the same head position as the character. You can give this a namespace, helmet. So Maya is not confused with namings, because in Maya you cannot have 2 objects to have the same name. But with namespaces you can, because it's still the namespace and then the root. So if you created this, you could go in there, just quickly copy the joint of the head, call it helmet base, and then you can create a new joint. So I have a joint now here, you can see it. This joint needs to be placed where basically the hinge of this thing is. I'm just gonna do it like really dirty and quickly, but usually the character artist can already give you a really good position for the pivot. I'm gonna align it, and then I'm gonna freeze transformations. Okay, now we have one joint here. The joint is aligned kinda to this thing, to the flap. And we have a helmet base. We call this helmet left flap. Parent it under it. So we have the helmet flap, and it's aligned to this thing. So we need to skin it because we want to have skinning information on it. And we have these 2 joints. You can go in there, This is now really Maya specific. You need to go to bind skin. You can have now paint skin weight tools. You go in, let's say the base is 100%. So basically if I move this, the base joint of the helmet will move. I then need to quickly get the neck, constrain the neck to the other one, and do the same for the head. Because now, if the animator moves the control now, the whole head moves and the helmet stays. This thing moves as well, and we want that if this joint that we just created, the flap, if this joint moves, the whole flap should move as well. How we can achieve this is we just isolate this. You can go to paint skin weight tools. You say like helmet flap that's on my joint should have 100% of influence. If you now select the joint and if you move it, you can see, all right, it's skin. It's kind of moving. I'm not going to do this for the right side. I'm just going to export it like this. So this is now my helmet, and I'm going to do the same as I did with the skin attachment. It's a cry export node. It's a skin, create. Maybe if I export it now, he will give me a warning and say like there's no material assigned. So I'm gonna export it here, rise helmet, export selected, and it says yes. Has a material that is not in a material group. So you go into the material group, you can select the helmet, say like add shaders from selected geometry, it will edit, and export helmet. So helmet exported. Now comes the fun part. You have the CRYENGINE here, and you see we still have only our base skeleton. We don't have like here the flaps that we just rigged, but we will get them as soon as we add the new skin attachment. So we can insert before. We say it's a skin attachment. Characters, player male, rise helmet. So you see, as soon as I added the helmet, he added some joints. Here are the joints that we just, because he looks for the skin attachment and he looks for the CHR, he compares all the joints, and then he sees like, okay, in this skin attachment there's only neck and head, and they are the same as in the other one. He gets the position and then he just extends the skeleton. That's like back in the days in Rise, we don't have this, so our main character had basically everything. He had, I think, like 6 swords, he had different skirts, different setups here, and a lot of joints, and the performance was really bad. And in the end, we had to fix all of this. So you want now this flap to be physicalized. So you don't see this replacement material. We can just give it something. Looks weird, but it kind of does the job. So to create now a physics attachment, or basically to say, I want one joint to be physicalized. It will override animation completely. So if you have animation on top of it, the physics will take over. You can go in there, say like insert before. Then you say, give it a name so you recognize it, helmet, left flap. And I usually say phys. So I already know, okay, that's the physics setup, that's all my physics stuff in it. Just keep it as a joint attachment and then say like, okay, which joint do you want? Right now, we did the helmet flap. You select the helmet flap. And here, I will then recreate it now with all of you. Just quickly with the arm, but just to see how it works. Here I have the flap. And I can go in there. Here, simulation is right now disabled. I have different forms of simulation. I have a pendulum cone, which is basically, it just simulates in a cone. I have a pendulum hinge, which simulates only on one axis, and like half cone, ellipsoid, and translational projection as well. So for this thing, because, hinge, exactly. It only moves on one axis, hinge is the best thing. So you can go there, you need to check this box, and you see this thing already looks like this. Why does it look like this? Because he tries to redirect the joint, and the simulation axis right now is on Y. Why? Because it's from X, and CRYENGINE, Y is forward. In Maya, Y is upward. So you can set the simulation axis to X because that's our main rule. Our X is following down the joint basically. Okay, so now it flaps around, but it flaps around in a different or in a wrong setup. You can have the debug setup on. With the debug setup, you can see like, okay, it's rotating just on this axis, and I wanted to rotate on a different axis. You can go in there and say hinge rotation. You rotate it, and you can directly see like, oh yeah, that's how I want it. I want it to be just like this. And you see that's the range from here to here. Maybe you don't want this. Maybe you want like a way bigger range. Maybe you want a smaller range. So you can define the ranges, you can define gravity, mass, like this should all be just normal physics setup. You can have the pivot offset, you can add a capsule to it, and whatever. So to see it, I can now put in my animation and go to the character. What is this? So redirect to joint. The cone angle a bit bigger, and usually should, yeah, you see it's moving, but like really you cannot really see it. So maybe just put in the mass to 8. Damping should be okay. Maybe put a little bit of joint spring in. So now you see it moves around. And you can tweak the settings. You can go in, say, yeah, I want the joint spring to be like this. So now it flaps around like this. You can have it like this, so it's now more stiff. And you can play with the values and do whatever you want with it. And that's how we did like all of the stuff. That's how we do hair. That's how we do all dangly stuff, dangly attachments. If you have a belt or anything hanging here, that's how I would basically do it with physics. And no animator has to like have a headache. So you can reset character. So for you, if you want to try this out now, right mouse button, insert before. So give it a name, like I showed it already now. Give it just anything, joint attachment. And now you can decide which joint do you want. You can try to take the head, you can try to take the arm and see what happens. I just gonna take the arm, right upper arm, and simulation, I'm just gonna do a pendulum cone. You can play with the settings and try different things out. So redirect, and you see the arm is already physicalized. If I now would play the animation, you see, the animation is completely overwritten. The root motion comes from the last joint that is not physicalized. So it would, in this case, it's the chest. Everything the chest does, the arm will just follow, physicalize it completely. You see, the base root motion is still kind of there. And yeah. You can also then just turn redirect off to see the difference with like normal animation, physics on. And you can tweak that, work with that. We had a setup where in Hunt, when the grunt is coming to you or an enemy, and you can shoot it. If you shoot it in the arm, it will basically turn the arm physicalized. It will then just do this, and the arm will just hang around, and dangling, he cannot attack you anymore. So that was like a really fast and easy way to solve this without like having to bother animation. This is really cool. You can edit on everything. You can maybe even have it running on some spine joints just to get like the feeling. So the physics is always on top. It looks like more natural. The animator doesn't have to do a lot of stuff. And that was skeleton extension. Yeah, okay, now I'm gonna show you the last thing. This is like really powerful. Like during Hunt, we really use this. During Hunt, we don't had a lot of animators. At some point, we only had one animator for, I think, like 25 different characters. So we thought about, okay, the animator, he cannot do everything alone. We need to try to solve as much as we can by code. by code and by runtime rigging. So what I will show you now is how to basically set up a simple look IK. Okay, an IK is basically an FK is this. I want to grab this bottle, I need to rotate my shoulder, I need to rotate my elbow, I need to rotate to get there. IK is basically I have one effector and a grab and everything else will just follow. That's a normal IK. And we can have this in the engine as well, which is like really cool. For that, you can just go in here, you can have modifiers, and it still says experimental. It's not really experimental, it just says it. And now you have a lot of modifiers, you have a constraint point. With this thing you can, maybe I can show it to you already, you should be able to just move the head. Let's say head. So if you do this, yeah, you can just, and the animation will still play. It's just an easy way to modify something, and this was the like easiest modifier, just a constraint point. So what I'm gonna show you now is basically the constraint aim. This is a really cool thing. Let's say you have a character in your game, it's an instructor. You go in there, you're first person, the character says something to you and you want that the character is facing you all the time. But you want to run around as a character, as a player, and do this, and the player should follow you all the time. That's what you do with a look IK. You can go in there and first you say, my driven node, so the node that basically, or the joint that would follow the aim, is my chest. Because like the chest, he will always point it and it will follow. Oh no, let's start with the head. It's, I think, better for understanding. Let's start with the head. So the head is the driven node. We say aim vector. What is the aim vector? You can basically say aim vector is 1 on y. It's, yeah, y up, exactly. But it's actually minus. And the up vector then is also minus. And the target node that you say is in Maya, there's already a joint. I created it. It's here. It's the target joint. This joint will be moved sometimes by the mouse input. So if you move the mouse, this joint will move around and the character will always aim at the joint. That's how you can, if you have a weapon and you have your aim target there, he will basically aim there. You will just move the target joint and he will automatically adjust the spine and adjust everything to it. This thing is exported already and it's called aim target. Just say aim target, it's this one. So he will try to aim at this target all the time. And the offset is okay, and you say the up node, because it's the character up node, he always needs to know like where's the character up, it's the root. Up offset is okay, weight is okay. Right now the head, as you can see it, is already now aiming. It's always aiming at this joint. So if I just move this joint around, I showed you this thing, target joint. So I'm just gonna fake the mouse input now. Let's say this is your target joint and usually your mouse should move it. Like as soon as you move it, you see the character will aim there. He will always look at this point, no matter where you go. But at some point, of course, he will break it because of the vector. Oh no, cool, he doesn't even. Cool, so the CRYENGINE is so powerful that it doesn't even break it. Usually it should break, but. Okay, let's say you have this done for the head. And the next thing is like you're not only moving your head, like the neck is following as well. So you can then go in, copy this whole thing, insert before, you just paste it, and then you just replace the head with the neck. Now you can see the neck adjusted. Now the neck is not this anymore, it's more like this. You can then have different targets again, and you can have different weight. This is the most important thing, because then you're gonna create another one, and the next joint would be then chest. So now he's adjusting the chest as well. But you don't want it to follow like 100%. You want that the head is following 100%. The neck should maybe just follow 60%, and then is the chest with something else. So you can go in there, say like, okay, it should just follow 60%, and the other one should follow 50%. And now if you move this around, he will then look with the head, look with the neck, and the whole upper body. And he will always aim at this joint and will always look at it. Yeah. And you can have the same for the legs. You can have IK legs if you want, and you can have like all kinds of runtime rigging without having the need for an animator, basically. And yeah, maybe I can show you a simple leg IK as well. For that, I need to quickly okay, so I added a joint. I copied the foot joint. It's just a left foot target, and because if we set up an IK, the IK needs a target joint, and the target joint is driving the whole IK chain. I can quickly play my scale. So if I re-export it, quickly save. That's a trick. To reload a character, just load a different one and then reload the player again. He should now have a target joint here. And the animation is still playing. So what we can do now is the IK2 segments. It basically just, like in Maya, it will create you an IK. That's what I already explained to you. Right now it's an FK, that's an IK. If I just select one control and I move it, the whole leg will move. Usually you have to do this in Maya, and usually this is not possible in any engines. But right now, like more and more engines adapt it because it's better to just on the fly change something. So in the engine, you say my root node is my thigh, because it's my left thigh. Here is the IK, is what it's starting. My link node is my knee, so it's the calf. And my end node is then the foot. So you see, it already moved here. So what I have now is my target joint that I just exported. Left foot target, so it will put it on the target. What I can do now is add another constraint point to then basically constrain the target and just to move it. So if I now move it, the whole leg moves with it. You see? There's no animation, nothing. As an IK2 segment, you only can define its 3-joint chain. But if you want to have like a tail, like let's say you have a big tail with like 20 joints, then you can use the CCD IK. It's called IK CCD. For the CCD, it basically then just have a root node. You can say like pelvis or start of the tail, and an end node. And then he will basically, if you rotate the end node, he will calculate the rotation and put it on every joint till the end of the. So this is also really possible. And yeah, if I have my diagnostic ROM, you see, usually my legs would move somewhere. Here, you see, you saw it. Yeah, you see? It's moving, but as my IK is holding it in place, I don't care about the animation so much. It's the same here, see? The IK just keeps it in place. You can use it for all of, like a lot of stuff. You can have it for ground alignment. Like let's say you have hills and you don't want the feet to clip into this thing. So you have ground alignment and IK on it. IK will basically just say, okay, that's my proxy of the surface, and I will now align my leg to the surface. So either like the animation can be like this, but if there's a surface here, you will basically do this. That's the runtime rigging, and this is like really, really powerful, and we saved a lot of hours just with this. Just to solve stuff like the character walks somewhere and the character touches something and then he twisted it. You can do this all without animation. Or just say my target joint is now here. I just retarget my hand to the target joint, rotate it, done. This will save like really hours of animation, because animation is a really, really time consuming thing. That's really just the basics. I think I could fill a whole day with it, and even a week or a month with rigging. The CDF, you can just place it as a CGF. The same way, you place it in the level, you can say like play an animation, done, and it will play it. To make this a playable character, that's another topic. Then we need code support as well. Cool, thank you very much.